Hi, I'm Neil Ewan from NIT Soak Technical. Today we're going to be changing the vertical shaft gear on a Bernina 730. It's important to know that there are two models of 730s. There was one made from 1963 through 1966 using a PSE motor. You can tell from the outside of the machine which motor this is because you will find two separate cables, a power cable, and then you'll find a two-prong plug cable that plugs into the motor cover just below the hand wheel. The second machine was made from 1967 through 1971, and it used the EPL motor. The vertical shaft gear change, however, between the two models is the same. The first thing that we're going to do is to remove the covers. In this case, I'm going to remove the top cover because we want to be able to film inside. I've removed already the stitch width knob, needle position knob, and the internal components linking those in the machine. That will allow us to actually see what we're doing in the machine. You don't have to remove these for making this change, but for the purpose of making this video, this is important. Because the vertical shaft gear is located under the main shaft, we need clearance to remove the broken gear. To do that, we are going to remove some parts below the gear, loosen the gear screws, and remove the vertical shaft through the bottom of the machine. Motor cover. We're going to remove the belts, and we're going to remove the step pulley. Step pulley is important to remove. It's a lot easier to deal with here. Thanks to Max Bauman tools. You have to see the tool lady for that. We're going to remove the hand wheel in this case. The top belt. The spool support. The spool support loose like this. We'll now pull the motor wires off. Then loosen the bottom screws. Leave the motor on the base plate. Now we have a spring that attaches for the knee lift. It's on this little pin. You have to be careful in taking that off. Now we have this off. We're good to go. Okay, now we're going to be sliding the main shaft gear back so that we can expose a vertical shaft gear. Vertical shaft gear is going to have to come up against the main shaft in order for us to get the rest of the components out. But right here, because of oil varnishes, this gear is almost always tight on the main shaft. This is one of my favorite tools that I use in the workshop here. We're working on older Swiss-made Bernina machines to help me loosen collars and gears with oil varnishes in rebuilding older Bernina machines. It is the same screw dimension as what you'll find in the main shaft bevel gear as well as in the vertical shaft gear. It may be of interest to know that early model 730 machines use straight miter bevels. And if you have to change a vertical shaft gear, you're going to be forced to pull the main shaft out and acquire a new helical bevel gear, main shaft bevel gear, so that you have mating gears. We will always find oil varnishes on this shaft, and so the gear is going to be stuck to the shaft. An easy way that I found to get the gear loose is we'll loosen the screw. I've already loosened the second screw on the main shaft bevel gear. Now the first screw will be 120 degrees from the second screw in the direction of rotation. Right here, what we're going to do now is take a little bit of lacquer thinner, best lacquer thinner that I found for this application. That's the most soluble for oil varnish is that you find in Home Depot. We're going to squirt a little bit of lacquer thinner in the hole, and now we're going to take the screw shaft here and screw it in. And then we're going to take that and start wiggling it, and as I start to move it like that, pretty soon it becomes free, and then I can slide that all the way back. It's almost free. We'll take a little bit more lacquer thinner in there, and then start spinning the shaft and slide it around. Then you can wash it off with a mineral spirits if you want. Another important thing to know about Bernina, the Bernina OEM gear, is that the teeth in the gear are timed to the first screw on this gear. Aftermarket gears made by different manufacturers, the tooth timing is not timed to the first screw position. You will have to retime the machine. Okay, what we're going to do next is we're going to remove the crank pin and the hook crank. We're going to move aside the connecting rod to the rack, and we're going to then remove the tracer lever from the bottom of the machine. Tracer lever actually traces the eccentric movement for the feed dog lift. Loosen this screw. Remove the snap ring on the crank pin. Now these parts are usually stuck tight with oil varnish again, and it's very difficult to get the pin out trying to pull it out this way, and the problem is when we try to pull the pin out this way, we generally take this connecting rod, which is a precision alignment, and we're bending that rod down this way, and then the machine is tight when we get done. That's a no-no. So let's do this the right way. What we'll need to do is we'll have to turn the machine to a position where I can actually take the crank pin and knock it through the hook crank, and it won't take much to do that. But trying to get it out the other way is very difficult. So here I'm just using the end of a #1 screwdriver, again using Balma tools. And here we are. We've moved that crank pin, it fell inside the machine. Now this connecting rod is free. We're going to swing the connecting rod down and out of the way. Like that. And now we're going to remove the first and second screws of the hook crank. Keep in mind that the first screw is the one that's turning in the direction of motion this way. This one has a flat end on it. The other screw in the middle here is a conical screw, and it's made to burrow into an undercut on the base of the vertical shaft to fix a loop lift position. This is a kind of a neat feature because Bernina machines, once that is done, they don't come out of time. They never do. So here we go. Remove this one, and then we will remove the other one. And now let's take this one out just for good measure. We don't like to have anything sticking out there. It makes the hook crank a little more difficult to get in and out. What I'm going to do now is pull the vertical shaft down against the main shaft. So here we can kind of give it a gentle push, and it's kind of stuck. But if we push a little bit more, sometimes we have to add a little bit of lacquer thinner in there, and that will break free some of the oil varnish. When that's done, we can turn the hook crank to about this position. You can see where the lines across on the flats, and then we can pull that crank out. I've loosened the hook crank screws, but in this case, the hook crank will not come out. Sometimes the vertical shaft can be set in the machine so that the shaft is set a little bit low, and when it is, then we have to go back onto the vertical shaft gear, loosen the screws on that, and then push the shaft back down through. So this is what we're going to do now. Let's push that back down. And now if we can hold the shaft right here, we can pull that hook crank back up. Okay, hook crank is out. Next, we want to remove the tracer lever, and this makes it a little bit easier. We want to clean this mainly because it has oil varnish as well, and we do the same thing with this particular lever, where we're going to remove the E-clip on it and the fiber washer, and then we can go through the end of the machine. There's a screw here that holds that axle in place. It's a pivot axle for this eccentric follower. We can now push that all the way through to the inside of the machine. Now we can remove this guy. Let's let it fall, it won't matter. And now, at that point, we can pull the vertical shaft out. I've made another little tool among several tools for the 730 machine. This is just a T-handle tool with a 7mm hole in it. It has a couple of set screws. And what I do is I can install this on the end of the vertical shaft. And remember, there's an undercut on the vertical shaft. What we're going to try to do is to get the screws to set on that undercut. That way when we tighten the screws, we won't damage the shaft at all. So we'll tighten this one. And we'll turn that over, tighten the second one. You don't have to tighten them tight, they're just kind of firmed up. So we'll make sure that the screws on the vertical shaft gear are totally loose, or you can simply remove them altogether. So now we'll take the shaft and we'll start to pull it out. It comes out relatively easy. Okay, you can see the damage on the shaft here. What I will do is take a hone stone like I've got here, and then I will simply, this is a fine India by the way, and I'll simply stone off the high spots or the swelled area where that screw is. What I can do to make sure that I have it's dimensionally correct and it doesn't stick, I can take either the vertical shaft gear or I can take the hook crank and I can install the shaft and I can push it through. And if it goes through relatively easy like this, as you can see here, there's a little bit of a tight spot. And we can get rid of that. There we go. Okay. So it goes right through. What I'll do is I'll take some metal cloth and I can use something like a 600 grit or finer, and we can clean this up. And then to make it really nice is we can use a buffer with green chrome oxide. Don't dwell too long in the buffer, just polish it out lightly. And you've got a good vertical shaft again. If we remove the screws on the vertical shaft like this from this tool and we pull that out, I want to make sure that the screws didn't damage anything. And we can also check it again in the bore of the hook crank, and here it goes right through it. And you can see the dimple or the conical hole that the fixing screw of the hook crank made previously. When we put this back together, we will not necessarily use that screw hole. If we wanted to use the marked hole in there, and we could do that, I suppose, because we're using the same hook crank again, but it becomes kind of difficult to do. In this case, I'm just going to reset the entire machine. What I'm going to do now is make sure that the shaft fits in the new gear. This gear, by the way, is one of the few that I have left, which is an OEM helical vertical shaft gear. And you can see that there is a flat on the shaft and a hole. And what this hole does is there's a hole through the top and it intersects with this hole. So when you put oil in here, it actually lubricates the top bearing. The top bearing has a slot in it, so a certain amount of oil will run down the shaft and lubricate the lower bearing. That's the way this is lubricated. Early model 730s were fitted with sintered bronze bearings on the vertical shaft on top and bottom, and there is no lubrication hole here. So if you're lubricating the machine, you'll have to turn it upside down and put a drop of oil to run down the bearing on both top and bottom. We're going to install the vertical shaft through the bottom bearing. We'll put a small drop of lubricant, and here again I'm using Kluber 68. You can also use one of the other 68 oils like Dectal R&O or Mobile DTE Heavy Medium. It's not a problem, that's what was made, the machine was made to use those oils. And this will give me some preliminary lubrication. I have the flat positioned up so I can see it. That way when I install this, I can make sure that one of these screws is on the flat. And we'll use our T-handle tool again so that we install it on the shaft. We'll be able to locate it. We can feel it rather than trying to pinch our fingers on the inside. Okay, locating the screw on the flat. There we are. And here I'm going to hold the gear, and you can see that I can feel the play very slightly. So I know that that screw is on the flat, and we're going to set that screw in place. Generally speaking, we want to have the shaft about flush with the top of the gear. We're now going to install the lifting lever, the tracer lifting lever. And so we'll give it a little lubricant here on the shaft. That's all we'll need for the next 20 years. Okay. And we'll tighten the screw that holds that in place. We have access holes through the end of the machine just for that. Here I'm going to use a synthetic grease, very, very small. Bottom of the tracer, we also call it a stylus. And then we're going to set this in place right on the lifting lever. And now you can see where the tracer is, the stylus or tracer. We're going to pull this all the way down so that when I slide the hook crank back in place, the hook crank is going to hit the back side of that lever and miss knocking off this little stylus or tracer. And I'm going to hold that down with my finger like that. Let's move the connecting rod to the side. And we're going to put this back in place. And we're sliding on and down. Now when I push it against the tracer, the back side of that tracer lever, now I'm going to hold the hook crank in place and I'm going to push the vertical shaft home, all the way down. When I push back and forth, I don't want to feel any axial play at all. In this case, with the new gear, it looks like I'm going to have to shift the shaft down just a little bit. And what I'm going to do now is to put my screws back in place on the hook crank and then put the connecting rod back in place. And I'm going to set the first screw, which is the first screw in the direction of rotation, which is flatted on the end. I'm going to set it provisionally, just finger tight. That's it. We do not want to tighten the conical screw. To recap, what we've done is we've removed the vertical shaft gear, the old one. We removed the vertical shaft. We've cleaned the shafting. We've checked the bearings for free running of the shaft. We have cleaned all of the parts to make sure they're clean. We've added only 1 drop of lubricant per bearing, which is plenty sufficient lubricant on this machine for a long time. We've gone ahead, as I mentioned, in the direction of rotation, which is this direction here. You can see the shaft rotating. The first screw that comes up is the screw that has the flatted point to it. And what we've done is we've finger tighted that screw against the shaft. The reason being is that when we make the adjustment of loop lift, the hook crank to be totally loose on the shaft, we want some resistance, and by tightening this only finger tight, a good finger tightening, that will allow us to move this hook crank and fix a position. And then later, when we know that our loop lift is set perfectly, we will then tighten this screw. Then we'll go back with our loop lift gauges, check and make sure it's correct. Then we will go back and tighten the conical screw and make sure it burrows into a new spot on the shaft. And when we put this shaft back in place, we want to make sure that that conical hole is not in the same place it was before. The reason being is that the teeth on a vertical shaft gear are not necessarily aligned with the screw positions, especially when you buy an aftermarket gear. They're totally off. So there's no way that you can put that gear back together without setting return motion of loop lift again. We are now ready to reassemble the machine, and so we'll go ahead and do that. Okay. Here. This concludes the replacement of the vertical shaft gear. We hope that you found this video useful. Next time we'll be talking about timing the machine. Thanks for being with us. We'll see you again.